Okay, so let's talk about cyber and data analytics. This presentation goes against every rule that we've given you in terms of presentation. There's a whole lot of information on here. It is not a presentation that's designed to be talked through, but it's really an informative means to get a lot of information for you. We don't have a big reading this week, so I tried to cram a lot of information into this. So study these charts, kind of know what we're trying to talk about here. What is cyber? For our purposes, we're going to refer to cyber as anything involving computers and networks. So there's two big sides of this. There's information security and network security. And when people talk about information security, what they mean is how you're protecting the information of the country. And that can cover a lot of aspects: access rules, facility protection, all that kind of stuff. Network security is how are you protecting the means to share that information. So the network itself is often an access means. So cyber can involve both of those. We're really going to want to distinguish between the two because that network security is a key element that strictly has to do with networks and computers and all that. What I do in this chart, and I want you to just go ahead and spend some time with this, is what I'm trying to do in the next couple of presentations here is walk through how do you actually get to the point. If you're not a software person or you're not a computer science person or electrical engineer, you may not understand this, but basically what I want you to know is how do you build up a network and understand how communication is going across of it. You start with a wire. You know, there's a current on and off. That's binary. So people talk about bits, right? That's what they mean. Bit, on, off. 1, 0. Morse code is, one way to do that. So on, off, on, you wait intervals. But what we do on the computers is we have a bus, right? That's going to have 8 wires on it or 16 wires on it, 32 wires on it. And each one of them, the on or off, based on what the charge is. And that on or off will give you a series of 1s and 0s there. And if you combine those, 8 of them, into a certain combination, they basically get interpreted into a letter. That's called ASCII, American Standards Group. And that's how you create letters. So every time the clock cycles, you heard a clock cycle. So the megahertz on a clock cycle. That means every time that thing has a cycle, it's going to be on and off in some combination, and you're going to be sending a character out there. That's how you get information across. Great, but that's only point to point. You're not going to wire every machine, right, to each other. So you have to create addresses. For all these things to connect. That's your internet protocol, right? That's your IP addresses. You'll send characters into envelopes that address them, switches and routers. And like a switchboard or something, your hubs and routers will be controlling who has access to who and where all that mail goes. Now you need software that can interpret all that data once it gets to the computer, package it up, and then create useful information out of it. So the next step here is you're not just sending those packages. I want to send actual data files. So now you need things like TCPIP over top of that that'll construct actual meaningful information out of it. And that's kind of what we talk to in this chart, which is, you separate the networking programs now from the computer and the actual application. So a lot of what we've got that we sort of rely on in terms of software modules, transmission control protocols, TCP/IP package, your internet software within the computer. You never see any of that stuff. It's just built on internet standards that are made to handle that low-level interpretation of 1s and 0s into something that can get all the way across the internet and come into your machine. Because we don't deal with that stuff on a day-to-day basis, we just assume that it's working. That's opportunity for people to take advantage of it, and that's where cyber kind of comes in. So what's the whole picture? You've got this OSI stack, what they call the Open Systems International stack. At the application layer, you've got all the software that you're actually doing useful stuff with. That is on top of a presentation layer, right, which does the encryption and whatever you enter into the machine. It does all that. There's a session layer that maintains your session with the network. There's a transport layer that says, here's how we're going to transport all that stuff across the network. There's a network layer that says, here's how we're going to communicate between the different LANs and WANs and such. A data link that actually does the packets, and then the physical layer, which is the wires that essentially go out to the cable and the fiber and all that kind of stuff. And then when you come up to a new machine, you come on the other side and you go right back up that layer, right? So all the way up there, there's some transport and there's some conversions taking place. So you have to understand that, and then as we understand that, we understand at each different layers we're going to be capturing data. And we can capture that data, and we can look at that data, and we can identify when something's out of the ordinary. All right, that's the basics of cybersecurity. It's mostly defensive. Most of the time, it's encryption based. There's going to be malware prevention out there. Access control is a big player, right? Who has access to what? How do we ensure physical security? So if on closed networks, you're going to have physical security, and then authentication is a big one. So from an encryption standpoint, there are industry tools. They're pretty good. They're not perfect, but they're pretty good, and they can provide a false sense of security because they're by definition going to be sort of slower than the bad guys, right? Malware prevention is the same way. Someone's going to come up with something, and we got to figure out how to deal with it. Now, if they're targeting you specifically, you're not going to be able to deal with it fast enough. If they're targeting just in general, then a lot of times they can get patches, companies can get patches out there and you can deal with stuff. Access control and authentication are basically based on best practices, so that's organization by organization. But breaches and data spills, meaning data that gets outside of a system that it shouldn't be on, or gets outside of the system that's supposed to be, it's supposed to stay on, it gets onto a different system, those are happening on an increasing basis because of this recognition that encryption capabilities are being outpaced by the speed of decryption capabilities. So our companies are trying to encrypt things faster, but people are figuring out how to get through those faster. The hardware processing ability is giving the bad guys a leg up. And our virus patterns, so where we detect sort of viruses out there, generally there's always going to be a lag. It's called the zero-day attack. Zero-day attacks are mostly undefended by industry tools that are out there. And then there's advanced persistent threats, something they load on a machine. You don't know it's there until it finally decides to rear its head and do something. And then there's insiders. So inside information that bypasses policy protections. A lot of attackers have that inside information. Because they're going to be targeting you, they're going to use a lot of different means, right? They're using that human to come around the network protections and get bypasses into that. Social engineering is one way to do that. And then a lot of times, just basic disruptions can kill capability without even touching the systems. So if you can shut down or overflow a router, or just fill you up with a bunch of garbage information that you have to deal with, that can cut off your ability to just do the business that you're trying to do. If you're trying to schedule transportation for a military, and you're having to deal with a bunch of messages that are coming in, they may not be able to getting into your system, but they're filling up your ability to actually getting your messages out. So it's like cutting off your water supply. Those are all real things that we have to deal with. We have to recognize, and the Department of Defense is recognizing the front lines of any of these new wars are going to be cyber. The reality is, we talk. I'm here in St. Louis. We're right from Scott Air Force Base, and that's like the front lines really of any major conflict. The first thing that anyone's going to do is try to disable the logistics network at Scott Air Force Base, because if you can do that, then you can shut down our ability to respond to anything. And that's kind of the reality. It's no longer a tanks charging across the Fulda Gap in Europe are the first shots. The first shots fired are going to be on the network. And we can't rely on commercial networks. They're not going to be much help either. So you need a better way to protect that infrastructure. And that means you need to understand the colors and the contours of the battle that's coming, and some analytical capabilities that can give you the ability to represent networks and understand when you're actually under an attack. So cyber analytics play into that. Our typical approaches are physical, right? We understand maps of server locations and connections and all that stuff. But that's a flawed way to look at a network, because attackers hop from device to device, within and without, outside of other host countries. They can emerge, their attacks can emerge from anywhere, and it can be long after the attackers have actually had access. So they may operate on a specific port, they can hide in normal traffic and normal load patterns, those kinds of things. So you need to understand from an analytics perspective what's normal, what's out of normal, and how do we deal with these things. Typical operations are you're going to be operating at a high fidelity, right, at some of your low levels, so you have some automated policies in place. You'll have some reduced fidelity at the higher level, so your network metrics, and malware can simply hide within these policies and keep from showing up on the higher level metrics, right? If you think you're okay because you're just looking at metrics, then that won't be able to detect. So you need some sort of asymmetric detection capability. What I mean by that is something that's outside of what the attackers actually understand is your defensive capability. So you need to be able to identify their behavior, basically, by the activity you see on the network. That means that whatever they're trying to do, they have some targeted approach that they're going to take. If you know basically can tell their very presence, right, regardless of the approach they're taking, then that's asymmetric. That's something they necessarily can't deal with, so they'll have to come up with something else. You bypass that automated rule set and that false positive danger by making it alert driven, right? And you also want to have a staff that's capable of understanding and dealing with alerts. This is one of the big problems we have with cyber and networks and security in general. Security folks aren't always the computer science people or the electrical engineering people or the people that really have that sort of deep technical understanding. And to really handle the network, you need cyber warriors that understand the behavior of this network and know how to fight within this network, and they need to be embedded in your security department. We tend to think of security just like IT as sort of a necessary evil, like keep the lowest cost, but make sure we're protected. What we really need are very, very sharp people within this part of the security department that can understand the network and be able to intuit what's going on based on behavior that they see there. So example, here we've got an example that we're going to kind of walk through. And all I want to do is in the next couple of charts is show you from an analytics perspective that you can gather a year's worth of data. What you needed to have in order to really use analytics is have someone who can understand what each of these states mean, right? Here we're looking at the network, we're looking at the home counties by state, we're looking at the number of seconds, we're looking at the number of counts of network accesses. You're visualizing those as you go across into the middle column in terms of the attack profiles, and then you're visualizing how many of them are we having, the source of the counts, and then you keep moving from there. You dig into a little farther. Are any of these from places that we know are going to be problem areas, and then dig into that further. To really understand this stuff, you've got to be able to get the data tools to represent this, the data tools to visualize it, but then you also have to have people that understand enough about the system that they can relate visually what the analytics tools are telling them to what's going on in the network, and then can translate that back. And those are the analysts. You know, who uses cyber data? It's not just your typical analysts. It's operations managers, it's your network engineers, your network security personnel, and then your other analysts that would be on the network. They operate on a 24/7, 365 basis because your networks are constantly under attack. You're not preparing for a conflict in this situation. You're actively managing a conflict that's already afoot. As soon as you plug in any of these companies that are listed here, or in any of the security departments, or in the IC, or in the Department of Defense, you are constantly under attack. And so what you're really doing is managing this conflict that's already afoot and making sure that you're keeping yourself protected as well as you can. And finally, you expect the unexpected and detect the unexpected. That's the real challenge here. Anomaly detection is becoming more and more important. That is how you drive success within cyber protection. And detecting anomalies is like detecting those out of condition variables that we talked about in the second week. What's odd that's happening, and how do we translate that into something that we can say pretty sure is some kind of a threat that may be attacking us. We can't look at everything that's different and shut down the network every time, but we've got to be smart and we've got to be able to use those defenses intelligently so that we can protect ourselves. It's not all that different from other defenses, right? You're looking for something strange, identifying threats, and acting on them. What does it look like on a normal day? What does our network look like on a normal day? Is there anything different happening today? That's how we look at those zero-day attacks and understand if there's anything that we need to be careful about. You have detection algorithms, behavioral algorithms, and artificial intelligence. All those should be feeding into alerts, diagnostics, and recommendations that help you drive on a day-to-day basis, hour by hour, minute by minute, what's going on with the network. Organizations suffer if they think the network is a utility and they only need operators to keep the network up and down. That's not going to work. It's a battleground. You need to understand the changing dynamic of that. You need to have strategies to respond to that evolving threat. Path forward is that we need to protect our information. It's the lifeblood. Cyber protection is not a housekeeping duty. It is something that we need to have professionals armed and the smartest people we can get our arms around involved and engaged with this process as we go forward. They'll learn to rely on improved data and analytics in the environment that they're supposed to protect.